Okay, so today we're going to solve absolute value inequalities. So take a look at the try this. I just want to refresh your memory with the set notation and interval notation. So when something is graphed out, like this, we have an open circle here on 4, an open circle on -1. The set notation, you would use the word or. So it would be x is greater than 4, no equal sign because of it's not filled in the circle, and x is less than -1, and that's for all values of x such that. And using interval notation, you still use the word or. So for the greater than 4, parentheses 4, and that goes to infinity. And on the other side, it goes from -infinity to -1, and that's a parentheses also. And just take a look at 2. It's shaded, might be a little hard to see, but you probably see it on your paper better. It's shaded in between -5 and 8. When it's shaded in between, that's an and. You put x in the middle. Less than or equal to, less than or equal to, because they're shaded. It's always less than. As long as you use less than, -5, the small number goes on the left, and 8, the larger number goes on the right. And using interval notation, it'll be bracket, -5, comma, to 8, bracket. So we will be using this today. All right, so let's take a look at the absolute value inequalities to solve. So this is very similar to the equations, except that when we're done, we have to put it on the number line. All right, so what I want you to do is change the inequality to an equal sign. And like we did before, you're going to isolate the absolute value. So this is the same. You're going to write two equations. This is the same as yesterday. We're going to solve both equations just like yesterday. So it's 4 through 7 that is new. But you've seen it before. We did it with the rational inequalities, and we did it with the quadratic inequalities. You're going to put your solutions on the number line. You're going to pick a test point in each interval. You're going to shade the appropriate interval and make sure that you can write the solution in various ways. All right, so let's take a look at number 1. So the first thing you're going to do is I want you to change the inequality to an equal sign. So I have the absolute value of 2x plus 3 is equal to 7. Is the absolute value isolated? Yes, so I'm going to branch off. So I have 2x plus 3 is equal to 7. 2x plus 3 equals -7. Two equations, one's for the inverse. Now you're going to solve. -3, 2x is equal to 4. Divide by 2, x is equal to 2. And on the right side, -3, 2x is equal to -10. Divide by 2, x is equal to -5. Okay, so now you're going to draw a number line. You're going to plot -5 and +2. There will be open circles because the inequality is a less than symbol. And now you're going to pick test points in each interval. So pick a number to the left of -5. I'm going to pick -6. In between, I'm going to pick 0. And to the right, I'm going to pick 3. You're going to plug it into the original. So that's going to be the absolute value of 2 times 6 plus 3. Is that less than 7? So it's the absolute value of 12 plus 3 is less than 7. 12 plus 3 is 15. The absolute value of 15 is 15. Is that less than 7? No, so I don't shade to the left. I'm going to try 0. 2 times 0 plus 3 is less than 7. 2 times 0 is 0 plus 3. 0 plus 3 is 3. 3 is less than 7. That's true, so I shade in between. Try 3. 2 times 3 plus 3 is less than 7. So that's 6 plus 3 is the absolute value of 9. 9 is less than 7. That's not true. So I don't shade to the left, to the right. Okay, and the last thing is to make sure that you can represent the answer multiple ways. So I have the shading in between. So it's for all values of x such that. Put x in the middle. I have less than 2. And I have -5 is less than x. And use an interval notation, be parentheses -5, comma 2 parentheses. Okay, so let's take a look at 2. Okay, so the first thing we're going to do is isolate change the the inequality, sorry, to an equal sign. So it's the absolute value of 6 minus 3x plus 4 is equal to 3x. And now I'm going to minus 4 to isolate. So it's the absolute value of 6 minus 3x is equal to negative 1. All right, now I'm going to branch off. I have 6 minus 3x is equal to negative 1. 6 minus 3x is equal to positive 1. And now I'm going to solve each one. So I'm going to minus 6. I get negative 3x is equal to negative 7. Divide by negative 3. I get x is equal to positive 7/3. If you want to put that into a decimal form, just so you know where to put it on the number line, you can, but leave it as a decimal in the end. Minus 6 on the right side. Negative 3x is equal to negative 5. Divide by negative 3. X is equal to positive 5/3. Okay, so on your number line, you're going to plot your points. So 5/3 is smaller than 7/3, and they will be closed circles. And then we have to pick some test points to plug it in. So a number to the left, I'm going to pick 0. A number in between, I'm going to pick 2. So you should change those, or just take a look in your calculator what those decimals are, so you can see what number to pick in between. And a number to the right, I'm going to pick 3. All right, and we're going to plug it into the original, please. So it's the absolute value of 6 minus 3 times 0 plus 4, close absolute value, sorry, plus 4 is greater than or equal to 3. Okay, so I have 6 minus 0. 6 minus 0 is 6, so it's the absolute value of 6. The absolute value of 6 is 6 plus 4. That's 10. Is that greater than or equal to 3? That's true, so I'm going to shade to the left. And now I'm going to try 2. So it's the absolute value of 6 minus 3 times 2 plus 4 is greater than or equal to 3. So that's 6 minus 6, which is 0. So 0 plus 4 is 4. Is that greater than or equal to 3? That's true also. So I'm going to shade in between. And now I'm going to try 3. The absolute value of 6 minus 3 times 3 plus 4 is greater than or equal to 3. So that's 6 minus 9, which is negative 3. The absolute value of negative 3 is 3 plus 4. Is that greater than or equal to 3? 7 is greater than or equal to 3, so that's true. So I shade to the right. So I told you guys, sometimes you can have these inequalities that just because it shades out doesn't necessarily mean that it doesn't shade in. So this is one of those incidents, one of these times when this is a special case where everything on the number line, when I plug it in to the equation, it'll work. So what's my answer for this? Is the solution set is all real numbers. Okay, so that's it, and have a good night, everyone.